Hello again. So, on my previous video, na-discuss natin dito tayo nag-end up sa single phase line. Okay? And then, I told you na magti-three phase na tayo and then I realized na meron pa nga pala tayong composite conductors. Okay? So, so for now, we'll talk about composite conductors muna in a single phase line. So, mag-stick muna tayo sa single phase kasi it's easier to discuss it this way. Kapag single phase muna ang inuna natin. So kailangan mabagal ako magsulat. So hindi ako pwede nagmamadali. Okay, sige. So hindi ako pwede nagmamadali. Okay. So what if instead of single solid conductor like this one, what if instead of a single solid conductor, yung ating single phase system is made up of conductors that is stranded siguro or bundled. Okay, like this one. Okay, so what if instead, yan, yung ating single phase dito, parang DC yata yung na drawing ko last time. Okay, anyway, sige. What if instead of solid line for this line and a solid line for this line, what if this line is made up of a composite conductors or a bundle of conductors? Okay, so hindi siya isang solid wire lang. And the same for this one. Now take note that on our previous discussions dito sa mga to, on our previous discussions, ang ating formula for inductance ay for a single wire. Okay, that is the inductance of a single wire. This one, kapag meron tayong multiple wires, then yung inductance natin ay nakukuha natin as inductance lang ng isang wire. And yung effect ng other wires, neighboring wires. Okay? Now, what's interesting dito in this case is that you have these two wires. Now, this wire has a current going this way. This wire has a current going this way. So you can say we can say that this set of conductors, this is conductor X, belongs to this wire where ang current sa kanya is going outwards towards us, and then this conductor belongs to this return path where ang current sa kanya is pabalik naman. Okay? So now, if we consider the inductance of, let's say, this conductor A, itong maliit na to, this is not yet ABC. Hindi pa to yung ABC na three-phase. This is still single phase. Okay? I think, sige, para hindi sa tayo malito, gamit tayo ng iba. Siguro, let's use the, hindi, wag na. Kasi on our equations, gagamitin natin siya as ABC. So, hayaan na lang natin. Okay? So, this is not yet your ABC na three-phase. Okay? Now, if we want to get the inductance of A, then it is affected by its self-inductance, yung kanyang internal inductance of A. Therefore, ang kinoconsider natin current sa kanya, yung current lang na nagpapass through kay A. So, if we have this total current, this is 10 amperes. If this is 10 amperes, then this 10 amperes will be divided into A, B, C, and N. Kung gaano man siya karami. Okay? So, siguro, kung apat siya, then I think kay conductor A, kung they are the same, maybe if they are identical conductors, then maybe kay conductor A, 2.5 yung magpapass through. Okay? So you have that self-inductance kay A, internal, and then yung external niya kay due to current kay A din. And then you have the external due to conductor B, the external due to conductor C, and the external due to conductor N. Also, you have the external due to conductor A prime, B prime, C prime, and M. However, take note that the currents here is negative because ito, ganito ang direction, this one, ganito yung direction. So, there is a difference in direction. So, the currents here is positive since it's the same direction as A. The current here is negative since it's opposite direction kay A. That's why in this formula, you'll see that the flux linkage, oops, the flux linkage on A, small a, this one, is, well, it's 2 times 10 to the negative 7 because it's always 2 times 10 to the negative 7 times Ix over n. Take note, Ix over n. So, it's equally divided sa kung ilan man yung conductors. So, I think it's under the assumption na identical conductors sila. Times ln of 1 over R1 prime. Okay, so I guess na-establish na natin that this represents the internal and the external inductance due to current on A. Then this is ln dAB because that is the distance between A and B. Take note that is center to center. Okay? You also have the distance between A and C, center to center. Sorry, hindi pantay yung sulat ko. Nag-pen na ako pero hindi pa rin maganda yung sulat ko. Up to what how many conductors man yung nandun. So A to N. Okay? Plus, of course, you have the 2 times 10 to the negative 7 ulit, this one. IY, take note, IY naman tayo kasi nandun na tayo sa return path over M, kung gaano naman sila karami, times ln ng 1 over dA A prime. dA A prime. So, it's center to center. dA B prime, center to center. dA C prime, center to center, and so on and so forth hanggang center to center km. Okay? Now, take note that IY, because this is single phase, so IY is just the negative of IX. So, we can represent that as I, and then, parang may, yeah. So, we can represent that as I, so you get this I, and then this ln na nakadivide siya. Okay? Parang baligtad yata ako. IY is negative of IX. IX, silent is IX. Yeah. I think negative I ang ginamit ko rito. Yeah, I think negative I ang ginamit ko dyan. Okay? But you're left with this equation. Where, ang maganda, the beauty of this equation is this large equation here, uy, naging black. May napindot yata ako. May nating blue. Can be simplified into this smaller equation. So mas maliit na siya ngayon. And then I think you get the idea that LA is just 2 times 10 to the negative 7. Sorry. Yeah. Wait, burahin natin. Sorry. I think you get the idea that LA, take note, this is just LA. This is just this L. Hindi pa siya yung buong conductor. Okay? Is equal to flux A over I. Take note, so you don't just cancel this. Okay? So yeah, I think yun lang yun. You don't just cancel this because this I is equal to this. Sorry, nagkamali ako rito. I forgot to put the negative here. But this negative I here is equal to negative X. Therefore, we are talking about the total current that is flowing into this whole conductor X, not just IA. Okay? So yeah, yun lang. And then, ayan. So yeah. This is IA. It's I divided by kung ilan naman yung conductors. That's IA. Okay, it's basically this one. Ito rin yan. Okay? Yeah, so this is the simplified version. If you're not sure kung paano nagkaroon ng M truth at saka N truth dito. Basically, ginawa natin, ipinasok natin tong N dito sa loob ng Ln. And this M sa loob ng Ln. Okay? So, yun lang. Okay, and then, yeah, I think that's how you get the inductance for a single phase composite conductors. Okay? Sige, sige. Sige, sige. Let's see. Ayoko pa sana pumunta rito eh. Pero sige. Okay. So, that is just LA. Of course, you also want to get LB, LC, and LN. But sabihin natin na nakuha na natin siya up to N. Okay? So to get the average of all, to get the inductance, average inductance of all the conductors here, of all of this. So what you want is just get LA, get LB, get LC, get LN, sum all of them, pagsama-samahin nyo lang siya and then divide it by 4 or how many conductors man sila. Okay, in this case, it's N conductors. So if you divide that, you get the average. Now, the thing about this is since all of the conductors are in parallel and you get this as average, then we can say that, yeah, I have these 4 conductors. All of them, well, they may be different, but they have an average value of a certain number. So I can assume that all of them on the average has this value. Okay, so let's say this is 10, this is 11, this is 12, this is 13. So that's 10 plus 11, 21, 33, 40, ilan yan? 46. Okay? And then on the average, maybe I have a 46 over 4 na inductance. Okay? So ganun siya. So if I have a 46 over 4, then maybe I can say that this is 46 over 4, this is 46 over 4, this is 46 over 4, this is 46 over 4. Tama ba yung 46? Yeah. Okay? So pare-pareha sila. Such that I have a 46 over 4 here. Since they are all in parallel, then pwede kong kunin yung total inductance nila. Such as 46 over 4 in parallel to 46 over 4, in parallel to 46 over 4, in parallel to 46 over 4. So I have a 46 over 4 divided by 4. So now I have a 46 over 4 squared. So that is basically this formula. You get a 46 over 4 squared. Or the summation of L's divided by n squared. Okay? And you can expand this formula. Okay? So now, kung mapapansin nyo, pinahaba muna natin yung equation. If we expand this formula, you'll find these LNs. And since they are all LNs, pwede nyo silang pagsama-samahin. You have the M truth, so pwede nyo pagsama-samahin yung M truth. You have the N truth, pwede nyo pagsama-samahin yung N truth. You can combine all N truths. Okay? And what can we notice about these M truths and N truths? For the M truths, it's the distance between A to A prime, A to B prime, A to M. It's basically the distances here, 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 and here multiplied. B to A prime, B to B prime, B to C prime, B to M, up to N to A prime, N to B prime, N to C prime, N to M. So that's basically all of those within M truth. All of those within N truth, that is lahat naman ng within the conductor. Okay, so since we are considering conductor X, so we get A prime, of course, yung self, then A to B, A to C, A to N. So yun yan. And then you have B prime, B to A, B to C, B to N, and so on and so forth hanggang N prime, B to A, N to A, N to B, N to C. And that is everything that you have under N truth. Okay? So pwede natin pagsama-samahin sila because they are all in Ln. And since they are all in Ln, then we can say that your L on conductor X, take note, conductor X na to, is just 2 times 10 to the negative 7 ln of GMD over GMR. So we call this GMD, where GMD is yung ating M-truth nung A patawid sa kabilang conductor X. A to B and A to M, and so on and so forth hanggang N to A, N to B, N to C, N to M. So that's your GMD. For the GMR, it's basically it's the geometric mean radius. It's para siyang GMD is the geometric mean distance. So it's like it's not the average distance, but it's the geometric mean of the distances between two conductors. Okay? So we consider this as two conductors, this X and Y, because, well, magkaiba yung current na dadaan sa kanila. Same in magnitude but opposite in direction. For the GMR naman, it's the para siyang self-distance. So it's the radius, well, it's A prime. You get A prime, that's just R prime. So yan yung R times e raised to negative 0.25. And then it's distance from B, distance from C, distance from N. So sir, bakit B, C, N? Because they are basically carrying the same current. It's basically carrying the same current na divide lang sa kanilang apat. So you don't go to A prime here sa GMR. A to A prime is within GMD. A to B is within GMR. A to B prime is within GMD. A to C is within GMR. And so on and so forth. Okay? So, ganun siya. And then you have NN. Okay? Sir, bakit siya naging M times N truth? Because of this one. Okay? So, pumasok lang siya dun sa loob ng LN. Okay? Ano pa? I think that's it. Yan na yung sa composite conductors. There is an example here. I'll upload the solution here sometime. Gagawin ko muna yung ibang lectures. And then, yeah, andito na tayo sa three-phase line. So, this is for another video. Itong mga to for single phase lang muna. Okay? But at least now you have an idea kung paano nagbe-behave yung inductance kapag merong mga conductors present. Lalo na kapag yung conductors na yun ay carrying different or same values of current. So yeah, I guess yun lang muna.